Imagine living on a planet where 1 hour equals 7 years on Earth. In the vastness of space, time warps in ways that defy logic. Here's why. Let's start with something familiar: the clock. A circle divided into 12 hours, 60 minutes, and 60 seconds. Or your phone, endlessly tracking appointments, birthdays, and deadlines. Time feels like the ultimate constant, an invisible thread pulling us from the past into the future. But here's the kicker. What we call time might not exist as we think. It does. For humans, time is a practical tool. Clocks and calendars help us organize our lives, plan for tomorrow, and remember yesterday. But in the grand tapestry of the universe, this carefully measured rhythm doesn't hold up. Albert Einstein shattered the idea of time as absolute over a century ago. According to his theory of relativity, time isn't fixed. It bends, stretches, and even slows down depending on factors like speed and gravity. Imagine this. You're standing still on Earth, watching someone speed away in a spaceship. For them, time moves differently than it does for you. The faster they travel, the slower their clock ticks compared to yours. It's not just science fiction, it's science fact. Astronauts aboard the International Space Station, orbiting Earth at thousands of miles per hour, actually age ever so slightly slower than people on the ground. Mind-blowing, right? But it gets even stranger. Philosophers and physicists alike ask, does time even exist outside of human perception? Without our clocks and our minds to measure it, does the universe itself recognize time? Or is it just a construct we've invented to make sense of change and motion? Here's a fun fact. Ancient civilizations didn't think about time the way we do. The Mayans, for instance, didn't have seconds or hours. They measured time in cycles, rituals, the phases of the moon, the alignment of planets. For them, time wasn't a line stretching endlessly forward. It was a circle, an eternal loop. But if time isn't absolute, if it's just relative, why does it feel so real? Why do we remember the past, but not the future? Why does every moment seem to march us forward inescapably? What do you think? Could it be that time is less real than it feels? Drop your thoughts in the comments below, because this is only the Ichoi beginning. But if time is relative, then how does it behave in the mind-boggling vastness of space? What happens when time is stretched to its limits? Buckle up, because that's where we're headed next. Could the speed of light be the one thing that ties the entire universe together? Think about it. Light is everywhere. It's in the glow of the stars, the warmth of the sun, and the beams of a flashlight cutting through the dark. But light isn't just a source of illumination. It's also the ultimate timekeeper of the cosmos, a constant in a universe where almost everything else is relative. The speed of light, 299,792 kilometers per second, is the fastest anything can travel. Nothing in the universe can exceed it. It's like the cosmic speed limit, and it shapes the way time behaves. To understand how, let's dive into something both extraordinary and mind-bending: time dilation. Imagine you're on a spaceship traveling close to the speed of light. As you accelerate, something incredible starts to happen. Time itself begins to slow down for you. From your perspective, everything seems normal, but back on Earth, the clocks are ticking faster. Days, months, even years might pass for those on the ground, while only a few moments go by for you. It's as if you've discovered a way to cheat time simply by moving faster. Here's a relatable analogy. Think of a video game with a slow motion feature. When you activate it, Your surroundings seem to crawl while you remain fully aware and in control. Now, imagine that happening in real life. The faster you move through space, the slower you move through time. This isn't science fiction. It's science fact, predicted by Einstein's theory of relativity and confirmed by experiments. And this phenomenon isn't just theoretical. It's happening right now. Astronauts aboard the International Space Station, hurtling around Earth at roughly 28,000 kilometers per hour, experience time slightly slower than we do. It's a tiny difference, fractions of a second over the course of a year. But it's there. In a way, they're time travelers, living a little behind the rest of us. So, what if you could slow time down just by moving faster? Could this be the key to exploring the farthest reaches of the universe? Imagine a future where we travel to distant stars, and when we return, centuries have passed on Earth. Light's speed isn't just a limit. It's a guide, a ruler, and a reminder of how interconnected time and space truly are. But as fascinating as this is, light's role as the universe's timekeeper is only part of the story. What happens when time bends in ways we can't even imagine? What happens in places where gravity is so intense that it warps time itself? Stick around, because next, we're diving into the strange and awe-inspiring concept of gravitational time dilation. What if I told you that time isn't just affected by speed, but by gravity itself? In the universe, time doesn't flow uniformly. It bends, stretches, and slows depending on where you are. This is the strange and mind-bending reality of gravitational time dilation, a phenomenon where massive objects like planets, stars, and even black holes warp time itself. To understand this, we need to go back to Einstein's general theory of relativity. In this groundbreaking theory, Einstein revealed that gravity isn't just a force pulling objects together, it's a warping of space and time, or what physicists call spacetime. Imagine placing a heavy bowling ball on a stretched rubber sheet. The ball creates a dip in the sheet, and smaller objects roll toward it. That's a simplified way to picture how massive objects, like stars and black holes, warp the very fabric of space-time. And when space-time bends, so does time. Here's how it works. The closer you are to a massive object, the stronger the pull of gravity, and the slower time moves for you compared to someone farther away. This isn't just theory. It's observable. Time moves slightly slower at the surface of Earth than it does at higher altitudes. If you're standing on a mountain, time is moving just a fraction of a second faster for you than for someone at sea level. You wouldn't notice the difference, but our technology does. GPS satellites orbiting high above Earth have to account for these time distortions caused by gravity to stay accurate. Without this adjustment, your GPS could be off by miles within a single day. Now, let's scale things up. Imagine being near a black hole, a cosmic giant so dense and massive that its gravity is almost incomprehensible. As you approach its event horizon, the boundary beyond which nothing can escape, time, would slow to a crawl. To an outside observer, it would seem as if you were frozen, hovering near the edge of the black hole forever. But from your perspective, you'd still experience time normally, even as the universe around you ages at an accelerated pace. What would that feel like? To stand near a black hole and watch the stars swirl and evolve as if on fast forward? It's a scenario that seems ripped from science fiction, yet it's grounded in the laws of physics. Gravitational time dilation isn't just a curiosity. It reshapes how we think about the universe. It shows us that time isn't a rigid, unchanging constant, but a malleable dimension, influenced by the presence of mass and energy. And it makes us wonder, if time bends and warps so dramatically in the presence of gravity, what might it look like at the edges of our universe, where the rules we know begin to break down. But there's still more to uncover. What happens when we look beyond gravity and speed to explore the edges of time itself? Could time have a beginning, or even an end? Stick around, because next, we're heading to the farthest reaches of the cosmos to explore the origins of time and what might lie beyond. Could black holes be the ultimate time machines of the universe? These mysterious, all-consuming cosmic giants have fascinated scientists and dreamers alike for decades. But black holes are more than just engines of destruction. They're places where time itself is stretched to its absolute limits. And here's the mind-bending question. Could falling into a black hole mean you're witnessing the end of the universe? To understand the role of black holes in warping time, let's start at the event horizon. This is the boundary surrounding a black hole, the point of no return where not even light can escape. For someone watching from a distance, anything falling toward the event horizon appears to slow down, moving in almost excruciatingly slow motion. From their perspective, time for the object, or person, seems to freeze entirely as it approaches the edge. But for the person falling in, time flows normally. It's like two versions of reality playing out simultaneously. One for the observer, one for the traveler. As you get closer to the black hole, the extreme gravity stretches and distorts space and time. Scientists call this phenomenon spaghettification. It's a rather light-hearted term for something terrifying. Your body would be stretched into a thin strand of particles by the immense gravitational forces. But what's truly fascinating is the way time behaves near a black hole. The closer you are to the event horizon, the slower time moves for you compared to the rest of the universe. A single second near the event horizon could equal years, or even centuries, for someone watching from afar. In essence, black holes are time machines, slowing time to an almost complete standstill. But what if we take it one step further? Some scientists speculate that black holes could be gateways to other parts of space-time. Theoretical concepts, like wormholes, suggest that falling into a black hole might not mean certain doom. It could mean stepping into another universe, or even another point in time. Of course, this is all highly speculative, and no one knows for sure what lies beyond the event horizon. But the idea of black holes as bridges to different times and places is one of the most tantalizing mysteries in astrophysics. Now, here's a question to spark your imagination. If you could somehow survive falling into a black hole, what would you see? Could you witness the past, present, and future all at once? Would you emerge on the other side of the universe, or find yourself at the very end of time? These are the questions that make black holes not just objects of fear, but of endless fascination. Black holes challenge everything we think we know about time and space. They reveal the incredible flexibility of time, bending and warping it in ways we can barely comprehend. But, as awe-inspiring as black holes are, there's still one more question to tackle. Could time itself have a beginning or an end? The next section, we'll take a journey to the very origin of time and what might lie beyond its horizon. Don't go anywhere. The story of time is far from over. What if you could age slower than your twin, simply by traveling through space? This isn't just a wild sci-fi concept. It's a real consequence of Einstein's theory of relativity. Known as the twin paradox, this famous thought experiment challenges everything we think we know about time, aging, and the nature of reality itself. Here's how it works. Imagine two twins, identical in every way. One stays on Earth, living a normal life, while the other embarks on a journey through space at near-light speed. For the traveling twin, time slows down significantly because of a phenomenon called time dilation. While the Earthbound twin experiences time at its usual pace, The twin hurtling through space ages far more slowly. When the traveling twin finally returns home, they find that years, or even decades, have passed for their sibling, while they've barely aged at all. This isn't just an abstract idea. Time dilation is a measurable effect that's been confirmed through experiments. Atomic clocks, which are incredibly precise, tick more slowly when they're on fast-moving spacecraft compared to clocks on Earth. In fact, astronauts aboard the International Space Station, orbiting Earth at thousands of kilometers per hour, experience this on a very small scale. After a year-long mission in space, an astronaut will have aged slightly less than someone who stayed on the ground. It's a tiny fraction of a second, but it's proof that time dilation is real. Now imagine scaling this up. What if you could travel at 90% or 99% of the speed of light? For you, time would move so slowly that a journey to a distant star might feel like just a few years, even though centuries could pass back on Earth. By the time you returned home, everything you once knew could be unrecognizable. Your twin now much older, perhaps even gone. It's an exhilarating but bittersweet thought. Exploring the cosmos might mean leaving behind the life you know for the sake of discovery and, ironically, youth. So, here's a question for you. Would you be willing to give up decades on Earth to explore the stars and stay young? Would the thrill of traveling through time and space outweigh the cost of losing touch with everything familiar? Let us know in the comments below. The twin paradox reminds us just how flexible and strange time truly is. It's not a rigid framework. It's a dance between motion, speed, and gravity. And as mind-bending as this thought experiment is, it's just one piece of the larger puzzle of time. Next, we'll tackle the ultimate question. Did time have a beginning, and could it ever come to an end? Stay tuned, because the mysteries of time are far from over. Is time travel fact or fiction? It's a question that has fueled countless sci-fi adventures, from Back to the Future to Interstellar. But beyond the realms of movies and imagination, could time travel actually be possible? The surprising answer is maybe. While we're far from building a functioning time machine, the science of time travel isn't entirely fiction. In fact, theoretical physics gives us some tantalizing possibilities. Let's start with wormholes. These hypothetical tunnels through spacetime, often called Einstein-Rosen bridges, could, in theory, connect distant points in the universe. Think of spacetime as a sheet of paper. If you fold the paper and punch a hole through it, you create a shortcut between 2 points. That's essentially what a wormhole would do. But here's where things get even weirder. Wormholes might not only connect space, they could also connect time. Traveling through a wormhole could allow you to emerge in a different era altogether, making it one of the most exciting possibilities for time travel. Another idea comes from the concept of closed time-like curves. These are paths in space-time that loop back on themselves, theoretically allowing someone to travel into the past and return to the present. It's a fascinating concept, but it raises some thorny questions. What happens if you go back in time and change something? Do you create a new timeline, or is the past already fixed? The famous grandfather paradox, where someone goes back in time and accidentally prevents their own existence, shows just how tricky traveling to the past could be. But here's the catch. Traveling to the future is actually much easier, at least in theory. Thanks to time dilation, as we discussed in earlier sections, moving at near light speed or being near an extremely strong gravitational field could allow you to experience time more slowly than the rest of the universe. When you return, you'd find yourself in the future. This kind of forward time travel is supported by Einstein's relativity, And we've already seen it happen in tiny increments with astronauts and atomic clocks. As for traveling to the past, that's where things get murky. Quantum mechanics, the branch of physics that deals with the behavior of particles on the smallest scales, might hold some clues. Some theories suggest that particles can borrow energy from the future, hinting at a strange relationship between time and quantum processes. Could understanding quantum mechanics unlock the secrets of time travel? Scientists like Kip Thorne, whose work inspired the movie Interstellar, have explored these possibilities with real equations. While we don't have definitive answers, the math shows that time travel, while improbable, isn't entirely impossible. So, here's a question for you. If time travel were real, would you go forward to see humanity's future? Or backward, to fix a mistake? Would you risk the unknown consequences of altering the past or embrace the mystery of what's to come? Let us know in the comments below. Time travel captures our imagination because it pushes the boundaries of what we believe is possible. It forces us to ask big questions about destiny, free will, and the nature of reality itself. And while we may not have time machines yet, the journey to understand the mysteries of time is far from over. In the next section, we'll take on the ultimate question. Did time itself have a beginning, or could it be infinite? Don't go anywhere. The answers may surprise you. What happens to time as the universe continues its endless expansion? It's a question that takes us to the edge of the cosmos, to the beginning of everything, and, perhaps, to the end. To understand the fate of time, we must first go back to its birth, the Big Bang. Around 13.8 billion years ago, the Big Bang didn't just create the universe, it created time itself. Before this moment, there was no before. Space, matter, energy, and time were all born in a single, unfathomably hot and dense explosion. Since then, the universe has been expanding, carrying galaxies farther and farther apart, stretching space-time itself like an inflating balloon. And here's the mind-blowing part. The farther we look into space, the farther back in time we see. Every glimmer of starlight that reaches us today began its journey billions of years ago, long before Earth even existed. But as the universe continues to expand, it faces an uncertain future, and time does too. One possibility lies in the concept of heat death. According to the second law of thermodynamics, entropy, or disorder, always increases over time. In billions or trillions of years, the universe could reach a state of maximum entropy, where all energy is evenly distributed, and no usable energy remains. Stars would burn out, galaxies would drift apart, and black holes would eventually evaporate. In this bleak scenario, the universe would become a cold, dark void, where nothing happens, and time, as we understand it, ceases to flow. Imagine what it would mean to exist in such a universe. If time no longer flows, would events still have meaning? Could existence even be possible without the passage of time? These are questions that push the limits of both science and philosophy. But is this truly the end of time? Some theories suggest that time could be cyclical, with the universe collapsing and rebirthing itself in an endless loop. Others propose that time might only exist as long as there are observers, like us, to measure it. As speculative as these ideas are, they remind us of the profound mysteries still left to unravel. So, what does it mean for us, living here and now, on a tiny blue planet in an ever-expanding universe? Perhaps it's a reminder to cherish the moments we have, knowing that time itself is precious and fleeting. But now, it's your turn. What do you think about the fate of time? Would you want to witness the universe's end or its rebirth? Drop your thoughts in the comments below. And don't forget to like, share, and subscribe for more journeys into the mysteries of the cosmos. Time might be one of the universe's greatest puzzles, but one thing is certain. The more we learn about it, the more it deepens our awe of the cosmos and our place within it. And as we explore the vastness of space and time, one thing is clear. This story is far from over. In the grand scale of the cosmos, time is fleeting, a tiny thread in an infinite tapestry. Yet, it's also the one thing that connects us all. From the ticking seconds of our daily lives to the billion-year lifetimes of stars, time shapes everything we experience, everything we are. It's the rhythm of the universe, binding together the past, present, and future into one continuous story. But here's the question that truly matters. How will you spend your time in this vast, mysterious universe? Will you chase your dreams, explore the unknown, or simply pause to savor the beauty of the moment? Time, for all its complexity, is also profoundly personal. It's your most precious resource, and it's always moving forward. As we've seen, time is far more than just the ticking of a clock. It bends and stretches, slows down and speeds up, and holds secrets that even the greatest minds are still trying to uncover. But no matter how it behaves on a cosmic scale, for you, it's happening right now. So, how will you make your mark in the time you've been given? Let us know your thoughts in the comments below. And if you've enjoyed this journey through the mysteries of time, don't forget to like, share, and subscribe. After all, exploring the universe together is the best way to spend our time. And with that, we leave you with one final thought. The universe is vast, but your time within it is uniquely yours. Use it wisely and make it extraordinary.